welcome to episode 3 of Making Tetris with SDL. And so last episode we created a window and we learnt about a basic game loop, and we also started handling some events. And we in particular handled the SDL quit event, which corresponds to when the user clicks the cross button of the application. And so in this episode we're going to actually create a renderer and start drawing something to the window, so we can actually see something come up on the window. And SDL has their own renderer, so it kind of so we don't have to use OpenGL or DirectX. Kind of whatever platform we're on, it uses the best option. So if we're on like a new Apple system, it would use Metal. If we're on Windows, it uses DirectX. So we're going to say create renderer SDL, and so this is the function we use. So you call create renderer, pass the window handle, some more information, and it passes back a SDL renderer pointer, which we can then use in later functions. So we can see an example down here. So they've created a window, then they create the renderer, then they load some bitmaps. We're not going to do that as of yet. We're just going to draw a coloured rectangle. And then they've got their game loop here. So they've got their infinite loop. They just keep running, and they're handling their quit event. So if the user quits, kind of break this infinite loop, and they're doing 3 functions that are important. So first they do a render clear, and what this does is clear the screen, kind of reset to a blank canvas. And we can change the color with another function, but we'll look at that in a soon. And so they do a render clear, which is a common thing, kind of, even when you're using OpenGL and things, it's called like, there's their own function that's like clear the buffer. Then we do a render, so they're doing a render copy, so they're drawing the bitmap to the screen, then they're doing a render present. We're not going to do the render copy, we're going to do a different thing called draw rectangle SDL. So there's a function called render draw rect, so we're going to use that instead of the bitmap one. And this function just takes the renderer handle and a pointer to some rect, which kind of has the information of the size of the rectangle. Then we're doing a very important function at the end, and we do this at the end of our frame. So we would have, if we had more draw functions, we would put them in between here. Then we're saying render present. And what this does is say, hey, we're finished rendering everything to the screen. OpenGL now kind of swap the buffers, put the new frame onto the screen, so display it to the user. And if the vSync's enabled, SDL will kind of use vSync, and what that means is it will sync up to the monitor refresh rate. So we kind of stick with a 60 kind of FPS or kind of 50 FPS kind of frames per second for our loop kind of cycling. So let's just kind of implement that for the moment. So we're going to create renderer function. So we'll copy that. So we're going to do that after we create a window. And we'll just bring it back over. So create renderer, we're going to call this a renderer equals SDL create renderer. We're going to pass our window handle, so that variable here. Then it wants, I'm going to put a semicolon, then it wants an index and flags. And what does this do? So the index of the rendering driver to initialize, or -1 to initialize the first one. So we're just going to say -1, hey, kind of, hey, SDL, you do this. We kind of want you to find the best fit, kind of best renderer for our one we're asking for. And this is more important when we're kind of, if we're asking for maybe more options, so like with our renderer flags, if we're kind of if we're ORing these together, we want the one that actually best fits what we're asking for. So, but we actually just want a render accelerated. So we want a render accelerated, so we want it hardware accelerated, so we don't want it software rendered. We want to use the GPU, so this is OpenGL or DirectX. And we also want to present it synchronized with the refresh rate. So we actually want to use vSync with ours. We want to say, hey, follow the monitor refresh rate. Don't update as like a billion times per second. Only update 60 FPS. So stick with the monitor refresh rate, and this stops tearing. And maybe later we can go talk about how this actually does it, but we'll just put VSync in there as well. So we're going to all those together. We get our renderer back, and then in our actual game loop, so this is where our program actually kind of completes its logic and runs, we're going to kind of follow the tutorial. So we're going to do our render clear function, and we can look at what this does. We're going to render clear SDL. So use this function to clear the rendering target with the drawing color. So basically just clear the buffer, clear the frame. We want a fresh start here at the beginning of our frame. So we're doing a render clear. We're going to do a draw rect, and this returns 0 on success. So we'll just do it for now without handling that error. So like we could do an if statement about if it doesn't succeed, and we might do that. So we won't do that for now. So we'll pass our renderer, and we would need a rect kind of. So what dimensions does our rectangle want to be? So we'll just create a variable called rect, and we need to pass the address of this because it wants a pointer. And then our information for our rect will say, and the attributes of these, so it takes an x value, and this is the top left corner of the rectangle, and we'll just say, hey, draw it at 0, rect.y, draw it at 0, and then the rect width, rect.w equals, say, 100 pixels wide, and rect.height equals 100 pixels as well. And next, final thing we're going to do is present our frame to the screen. So we're going to go render present. So we'll go back. Yep. And present it to the screen. Okay. So this should all work. So this should basically draw a rectangle to the screen. The last thing we're going to do is actually set the color. So SDL renderer set color. So this actually sets, it's kind of like a state machine, if that actually, if that makes any sense. But it kind of, the renderer remembers what the latest color was. So we don't actually pass it to, when we say render clear, say red. We actually don't do that. We set it before we actually call the function, and then that sticks around for all the kind of all the render calls after we say this function. And then to update it, we have to do it again. So we'll draw another one here. So we're going to like say, hey, clear the screen to yellow, and then draw a red rectangle. So to do this, we pass the render handle, and what's it asking for? It's asking for a red, a green, a blue, and an alpha, or opacity value. And UN8 is just an 8-bit value, so 0 to 255. And so this is common if you're familiar with Photoshop or kind of web colors. It's the value of the pixel, and so for red we would say, hey, 255. Actually, we'll do green. So yellow has red 255, green 255, has no blue component, and we want it to be full opacity. So we want it to be the kind of block, you can't see through it. Then we're also going to change this. So we'll draw a red rectangle. So I'll just delete that. So 255, 0, 0, and 255. So that's going to draw a red rectangle. So let's compile this and see if it actually works. So I'm going to open up my command prompt. I'm going to change directory into documents again, change it into Tetris. Whoop. Into Tetris. Then I'm going to run our build script. But again, we haven't installed our compiler, so we run our startup script. Then we run our build script. So it didn't get any errors, so theoretically this should work. So we'll have a go at it. So main.exe, and you'll see it's not actually doing anything. Well, it did actually do something there, so it took a while to do that. But it's not actually filling that in block color, like it's not filling all that red in, and it was very slow to do that. And the reason is this: we actually forgot to do one function that is very important to SDL, and it's called init SDL. And what this does is kind of gets SDL ready to actually draw stuff. So we'll go to this example in here, and so it's called SDL init. And so what this does is use this function to initialize the SDL library. So kind of initialize anything, kind of run any functions that need to be called to set it up, kind of query what system we're on, what kind of hardware acceleration it has, things like this. So it must be called before using most SDL functions. So we definitely need this, and we need to do it right at the start. And so it takes some flags, and we'll have a look at what this is. So basically, SDL has different modules that we can install. Kind of, we could just want audio, we could just want the video one, we could just want game controller. We're going to say, hey, SDL init everything, and so we say SDL init. We're going to do this right at the start of our program. So SDL init, and I think there was some uppercase there, so it looks like this. SDL init everything, and this returns returns 0 on success or a negative code on failure. So if it returns a negative is less than 0, something wrong happened. We just want to say assert false. Hey, something wrong happened. Stop the program. We want to know what happened. And what does assert do? Assert basically checks if the statement we pass is true or false, and if it's false, crash the program, stop everything, there's a bug in our program. So to actually get assert, we need to say include assert.h. And so basically it says init everything, if something failed, assert on our program. If not, this doesn't go into the if statement and it keeps going. So we will compile again, and we'll see if that actually fixed what our problem. So it's still taking a little bit long to actually do that, so that's not good. And maybe I'm running the streaming software, but I think it should actually work. The other thing I'm going to do is get rid of the vsync, so let's see what happens now. And we'll run out exe. So that's not a problem. And we'll look at the example and see if we're doing anything weird. So go back to our renderer. So we init it, we create a window, we create our renderer, and so we init everything, we create our window, we create our renderer, and then we go through, check if any events were called, we render draw color, so we set the color, we clear the screen, we draw a rect, so our 255 to 0, we set the color, then we draw the rect with these coordinates, and then we render present. So that should all work. And we'll just see if this works. So some other functions we can call, we can say, so draw rect is actually right. So so that should give us a rect outline. We actually want to do a fill rect to actually get a fill rect. So let's swap this for, instead of doing it as a rectangle outline, we will do a render fill rect, and this should actually fill it up. So call out exe, wait a little bit to initialize, and once it's initialized, yes, we get our red and it's filled up, we get our yellow background. And so the startup time, this must be because I'm using a streaming software, So on your computer it should actually kind of happen instantly. And so that's good. So we can now cross it, our events handle that, we're getting a red rectangle to the screen, we're presenting it, we've got VSync enabled, we've got hardware acceleration enabled, so everything's looking pretty damn good. And I'll just show you an example of what assert does before we finish. So I'll just say assert. So basically it's just going to hit this, no special case, it's just going to crash. So we'll run, and so we said assertion failed. Hey, in this file, on this line, this is the expression that it got, and so we can abort. And if we had a debugger, so if we were using Visual Studio to debug this, we could actually go through and see in more detail where that happened and what kind of data was there when it happened. So that's it for this episode, and in the next episode we'll actually start trying to draw our Tetris board and talk about arrays and how to kind of store our data for the game. So see you in the next video.